All right, last section of these notes. So this is, now we've talked about experiments, how you experiment well. Now we're going to talk about a very specific type of experiment design called block design, or sometimes called randomized block design. Okay, so in a block design, you're essentially taking your experimental units and breaking them into blocks. And then you randomly assign your treatment within the blocks. So it's very similar to stratified sampling from the first lesson. So blocks reduce variability so that you can actually see the effects of the treatment. Ooh. And sorry, my other tab just popped open on me. Okay. And then the blocks themselves are not treatments. So it's just how you're grouping your experimental units. They're another form of control, and they control the effects of some outside variables, right? So you're trying to control those confounding variables we talked about before. So a block is a group of experimental units that are known before the experiment to be similar in some way, and that way is expected to affect the response to the treatments. In a randomized block design, the random assignment of the experimental units to treatment is carried out separately within each block. So it's like a lot of heavy vocabulary we're going to break down. Okay. I'm going to leave all of this for you to pause and read. But the idea is you're trying to control what you can, right? So we talked about all of those design units up here. If we scroll back to the first part, where is that part of the notes? These designs. You want to control for variables that you can. But when you can't control for variables, scroll back down, you will block what you cannot control. And then once you block, you randomize to create comparable groups. So I put this here because I think they're very similar, but like, what's the difference between stratified sampling and block design? Well, sampling is a sampling method. So remember, that's like you're observing something, you're sending out a questionnaire. Block design is for experiments, okay? They're both trying to reduce variability. So what is the difference? If I was doing stratified sampling for the secondary school at Lincoln, I would have two strata, middle school and high school, and I'll take some samples from middle school students and some samples from high school students, right, and ask them a question. Block design is I'm imposing an experiment or some treatment onto the secondary students, right? And so I have 8 middle school students and 10 high school students in my sample. So I'm going to make 2 blocks, a middle school student block, a high school student block, and I'm going to assign these treatments, say it's medication versus no medication, in each block, right? So some middle schoolers will have medication, some won't. Why? Because I'm trying to account for the variability that exists between middle schoolers and high schoolers. So here's an example. A cell phone company is considering 2 different keyboard designs. Let's call them first one keyboard design A, second one keyboard design B for its new cell phones. So they want to test, how useful these different keyboards are. But what they noticed is they have this group of subjects, some who are frequent texters and really know how to text, and some that do not. And they know this is a variable that will impact the results of the experiment, right? So in this experiment, the subjects will be asked to text several different messages in 5 minutes on each of the keyboards. The response variable will be the number of correctly typed words. Explain why a randomized block design might be preferable to a completely randomized design for this experiment. So this question had a lot to write, so I went ahead and typed it for you, right? So why? Because a simple randomized design might not evenly split texters versus non-texters. You may have a situation where everyone who's does frequent texting, is really good at texting, gets keyboard A, and then the slow texters get keyboard B, and then it seems like keyboard A is better when that's not true, right? So that's why you block them to account for that variability of typing speed. So they are going to do a randomized block design. So how are we going to do that? Instead of typing this, I think I'm just going to do like a little filter. So let's do that. Let me get this. So you start with, actually do this. We have our 500, I know we have our 300 subjects, right? So what are we going to do? We are going to block them based on their experience. So let's do this. We have our experienced texters going up here, and then we're going to have our novice texters going here. So this will be 100 frequent texters, right? And then down here, we're going to have our 200 novice texters. I see that says testers, it's supposed to be testers, right? So we've blocked our design. So there's the blocking part. But now what we have to account for is the randomized part. So we have to randomly assign, right? So let me drop a little arrow. We're going to do, I'm actually going to do it like this. We're going to do something with random assignment. Okay, because we're going to randomly assign some people from block A to get keyboard A and some people from block the first block, some are going to get keyboard A, and we also want some from the first block to get keyboard B. So let's draw arrows. So we're going to have, you could actually have written a random assignment twice. You might like how that looks better because it looks more like a flow chart, right? But this one ends up being, oops, we're going to have 50 get keyboard A, and then we're going to have 50 get keyboard B. And then we have our novice texters. Well, 100 of those are going to get keyboard A. And then 100 of our novice texters are going to get keyboard B, right? So we've blocked for that variability of how good you are at texting. And then we're going to compare, what are they looking for again? Number of correctly typed words. So if you have to do this, we draw like another arrow. For some reason it's gone pink. And what are we doing? We are comparing number of correctly typed images, I think it was, right? Okay, so this is a block experiment, how you could draw design on an FRQ. All right, another type of block design is called a matched pairs design. You're still blocking, but then you're putting all of your subjects in pairs. So here's what it means. The idea is that you're creating blocks by matching pairs of similar experimental units, and then you decide which member of the pair gets one treatment and which the other person or the other experimental unit gets the other treatment. But just like other forms of blocking, what you're trying to do is to reduce variation. So if this is an example of a medical experiment, right? You have this group of people, they put these two guys together, they put these other two guys over here, and then they randomly assigned the two different green pill versus red pill to those pairs, right? The point is that you're matching pairs that have a likeness. So let's look at this one. Marathon runners are matched by weight, physical build, and running time. So they've put pairs of runners that have those similar attributes, and they're asked to test the durability of a new running shoe and compare it to the old shoe design. So they pair these guys off into similar weight, physical build, running times. They toss a coin to see which runner will get the new design versus the old design of the shoe, and then they look at the difference in wear pattern, okay? So sometimes that's a typical matched pairs design, but sometimes you can have a matched pair design that just has one experimental unit that gets both treatments. And in each case, the experimental unit serves its own control. And you have to think about the order of treatments because that can influence the response. So if I went back up here and I took one runner and I had them run a mile with the old design, then they came back and I gave them the new design of shoe and I asked them to run another mile, right? That would be the one unit getting both treatments, but that can impact your results because maybe the runner's running more slowly for the second mile because they're tired, right? So that's something you have to account for. So this is another one of those making it so that each subject gets both treatments. So in this example, it's a researcher who believes students are able to concentrate better if they listen to classical music. So to test the theory, they've done a matched pairs design, right? They put two students together. And I don't know, what does this say? Yes, because there's so much variability in problem solving abilities among students, a matched pairs design will be used to reduce variability so that any difference recorded can be attributed to the conditions under which the student completed a puzzle. So they have to complete a very specific puzzle. So they flip a coin to decide which order it's going to go in. But in this case, you can see student A has quiet, does a puzzle, then has classical music and does a puzzle. The idea is you're comparing your own controls, right? That student A is able to be compared quiet versus classical music. You do it again with student B. And then you have your next match pair and you run the same design. The idea is that there's some reason these two students are grouped together, and then you're randomizing the order of the treatments. And then that's it. This one was short. Okay, we are done with the notes. We only have one set of notes, and hopefully I will do those live. Talk to you later. Bye.